Okay, so you remember how this works. You got to use My Big Campus, use the discussion board, watch the videos, take the notes, be ready for class on Monday. As you can see, what we're going to be working on in class on Monday is multiplying polynomials by monomials. We spent a lot of time this last week defining and giving some characteristics for polynomials and monomials. You'll notice now that I'm going to start with a polynomial and take it and multiply it by a monomial instead of adding and subtracting like we have been. It sounds scary with those big words, but really it's something that will still use your background knowledge quite a bit. Using the distributive property and some rules of exponents, we can multiply any polynomial by a monomial. If you remember the distributive property from the last couple years, that a times b plus c equals ab plus ac. Remember, take whatever's outside the parentheses times each thing inside the parentheses. And then we went over a lot of rules of exponents in Unit 2, and you could look those up in your notes or on quizzes and tests. But the basic idea that you'll really need to know when we multiply a like base, remember the base stays the same, and then we add the exponents. That's really all you need to know, and then you'll kind of see how this applies. Looking at some examples, I want to simplify this expression. Now this one right here looks like something that we've actually done in our background knowledge. And so for this one, what we need to do is we need to take whatever's outside the parentheses, this monomial, and multiply it by this polynomial. And notice that's a special kind of polynomial right there. That means I'm going to take x times x, and I'm also going to take x times a positive 3. When we clean that up, x times x we know is x squared, and then x times 3 equals 3x. And you've now multiplied a monomial times a polynomial. So like I told you, it should be pretty quick and painless. It will get more difficult. You see here we have a 3-term polynomial, and then again we know what that special name would be. And then we also see that we have a monomial that we are going to multiply it by. To show my work, I'm going to take a negative 2x times everything in parentheses. Remember, I can always put a plus, but I have to keep track of the signs. And so notice some of the signs that I'm writing down as I'm doing this multiplication. Not done here whatsoever. Got to clean up each term of the polynomial. This first one, I'd have a negative 2 times 4, which would be a negative 8x to the third. Then you see that I also have a negative 2 times a negative 3, which would give me a positive 6, and x times x is x squared. And then finally negative 2x times 5, I could say that's plus a negative 10x, or I could just say minus 10x. Gives us a trinomial of the third degree, or a cubic trinomial. Let me give you another example of this, and you see how it might get a little messier for you, but the same basic rules are going to apply over and over and over again. I have 5xy squared times 3x squared minus 4xy plus y squared. So again, a monomial times a polynomial. Just distribute that out, and I would have 5xy squared times 3x squared plus 5xy squared times a negative 4xy, and then finally 5xy squared times y squared. Now here's where the rules of exponents really come in handy. Remember, we're going to multiply the coefficients first. 5 times 3 gives me 15. Then I have some like bases here, x and x squared. The exponent understood to be on x is 1. 1 plus 2 gives me x to the third, y squared. Then notice I have a 5 times a negative 4, which would give me a negative 20. And now I have x times x, which is x squared. And then I have y squared times y, which would be y cubed. And then finally, the last one, you see I have x times, whoops, a little messy on that one, x times y squared times y squared. X stays the same, so I have plus 5x, and then y squared times y squared would be y to the fourth. Tricky stuff here because we've talked about putting it in standard form and descending order. Notice each of these terms of the polynomial are all actually 5th degree terms. This is a 5th degree trinomial, and so what we would do here, notice the lead variable, the x, has the highest power in that first term, so we'd leave it like that, and that would be our answer after we multiply that monomial times a polynomial. You might see things that now actually build on that along with what we've been doing. And so you see in this one I need to distribute 2x, and then I also need to distribute x. I'll skip the distributing part or the multiplying part and just get straight to the simplifying. So I have 2x squared minus 6x plus 5x minus x squared. Now we're back to what we did last week, adding and subtracting. We're simplifying here, combining like terms. 2x squared minus x squared gives me 1x squared. And then I have a negative 6x plus 5x, and I get minus x. The last trickiest thing that we'll maybe spend some time on today or this week would be solving equations. And again, it involves multiplying a polynomial times a monomial and then actually doing a little equation. So notice we're solving because we've said that this whole expression actually is set equal to 0. First thing I got to do is simplify like I always would. Take the n times 2 and the n times a negative 5n. I end up with 2n minus 5n squared. Simplify this and you'll notice I get plus 5n squared minus 10. All of that equals 0. Nice thing that happens here is you'll see is your middle terms actually cancel out, and you're left with 2n minus 10 equals 0. And this actually isn't that difficult of a two-step equation to solve, and it's something you've actually been doing for quite some time, and n equals 5. As always, we could check this answer by substituting it back in to that original equation. One thing to copy down and check for yourself. I'd love to see you do this and try this one on your own. I do this on purpose. It's made to look intimidating, but really the bottom line is just got to do some multiplying, some simplifying, and then remember, if we have variables on both sides, we got to get them on one side. If you can copy this into your notes and you can get this correct for me by Monday, expect a definite reward. Otherwise, you should certainly have the notes from the examples that I did with you, and really, like I said, if you understand the distributive property and you understand the rules of exponents, then you should be able to multiply polynomials by monomials. See you on Monday.